Buenos días a todas y a todos. Es un placer estar aquí esta mañana con un montón de caras conocidas y ya todas amigas casi. Así que estoy encantada de poder dirigirles a todos unas palabras en esta apertura de la sesión plenaria de este segundo día del Big Science Industry Forum Spain, organizado por el CEDETI, al cual le quiero agradecer a Juan Antonio, al director, a todo el equipo que siempre hacen una tarea excelente y con el apoyo, por supuesto, de INEUSTAR y Induciencia. Ayer la sesión se dedicó a las infraestructuras nacionales y tuvisteis la oportunidad de discutir sobre el papel estratégico de nuestras ICTs, las infraestructuras científico-técnicas singulares, en el desarrollo de nuestra industria de la ciencia. Hoy vamos a continuar con esa conversación, con la conversación que empezamos ayer, viendo cómo estas infraestructuras nacionales conectan con las infraestructuras globales y cómo estas son un elemento clave en el desarrollo de nuestra industria española en relación con tecnologías claves. Una vez hecha esta pequeña introducción en español y en consideración con todos nuestros invitados internacionales, pues voy a cambiar a la lengua franca de estas reuniones. Good morning, ladies and gentlemen, colleagues and international colleagues and friends. As mentioned, yesterday's discussion highlighted what our ICTS, our scientific, technological, and unique infrastructures, whether geographically unique or distributed, are essential for competitive research. Their inclusion, the incorporation in the map of ICTS, updated lately, it was just for the period 2025-2028, ensures long-term planning, coordinated funding, and optimal use of European resources, such as structural funds. ICTS are committed to open access for public and private research communities and have a strong potential for technology transfer and industrial collaboration. Convinced of the importance of the research infrastructures as cornerstone of Europe and motor, the engine for making Europe globally stronger, and to achieve autonomous strategy, we need to strengthen collaboration between infrastructures, and we do it nationally. And of course, we have to expand this as well internationally. Linking our national infrastructures with global facilities to share resources and expertise, building a thorough ecosystem together with the rest of the stakeholders. Promote open science, ensuring knowledge flows freely and benefits society as a whole. Develop large-scale programs that advance fundamental science while delivering solutions for societal challenges. Big science is an engine of growth. Large research infrastructures have already demonstrated a strong potential for technology transfer and industrial collaboration. At national level, many companies have improved products or expanded services through access to our ICTS in fields like micro-nanotechnologies, supercomputing, and marine engineering. International organizations offer similar opportunities. Spanish industry can contribute to advanced detectors, superconducting magnets, precision optomechanics developments, computing systems, and sustainable energy solutions. With the recent launching of the European Strategy for Research and Technology Infrastructures last September, we expect an improved access for industry as providers, but also as users to research infrastructures beyond their essential role in the construction and upgrade of them. This strategic approach will enable companies to leverage these facilities for advanced design, testing, and innovation, fostering deeper integration between science and industry. Spanish companies have proven excellence in engineering and innovation. The next decade offers opportunity to supply critical components for global projects, lead in green technologies for scientific infrastructures, and collaborate in digital transformation, data analytics, AI, and quantum computing for research. For discuss about all of that, we are privileged to count today with the presence of the directors of ISO, Fusion for Energy, CERN, and IFMIF Donors, whose vision and leadership inspire our collective efforts. I would also like to seize the opportunity to point out the extraordinary work of the Deputy Director General for International Consortium Organizations and Research Infrastructures of the Ministry, which works tirelessly to ensure the best possible return of Spain's participation. Thank you very much, Emma. Thank you very much, Anna, and all the team. In these large research organizations working hand by hand with CDTI and especially with the department responsible for the industrial liaison offices in these organizations. Dear Roberto, the excellent work of your team as part of the Spanish delegation in the major international organizations Spain is member of, such as CERN, ISO, ESS, the European XFEL, Fusion for Energy, ILL, or Square Kilometre Array Observatory, is contributing to position our Industria de la Ciencia in the best situation to be granted with numerous and important contracts. Only for giving you some figures, in the last 15 years, the industrial return of our companies on competitive procurement processes amounts to 1,800 million euros, an annual turnover of close to 100 million euros in the last years. If we do a ranking, our position is extremely competitive in Fusion for Energy, where Spain currently is the third country in industrial return, or the fourth in the case of the European spallation source. It's also relevant the number of contracts of our companies, mainly in the sector of engineering and precision optomechanics in the construction of the extremely large telescope ELT of ESO. I would also like to take the opportunity to encourage all of you, our industry, to use the services many of the international organizations offer to the companies, like LEAPS, the European League of Synchrotrons, and like sources. In conclusions, big science is about more than answering fundamental questions. It is about shaping a sustainable, innovative, and competitive future. Yesterday's discussion on ICTS showed how national infrastructures can drive this vision. Today, let's us commit to build bridges between national and international efforts, ensuring that science remains a catalyst for progress and prosperity. I take also the opportunity here to thank also the Deputy Director also for ICTS, who is sitting close by, and the team, because together we make it possible. Thank you very much. Escuchemos ahora atentamente los mensajes que los directores que nos acompañan tienen que darnos sobre este asunto. Querida Mar, Xavier, Marc, Ángel, estamos ansiosos de escuchar vuestras diferentes perspectivas, así que vamos a ello. Thank you very much. Muchísimas gracias. Well, now I'm going to leave the floor to each of them, and we'll start with the presentation of CERN. Our first speaker is Dr. Marc Apeans, who currently is head of the Site and Civil Engineering Department at CERN, and who has been appointed Director of Operations starting January 2026. CERN is the leading research infrastructure that deals with particle physics worldwide, home to the most fascinating breakthrough discoveries in fundamental physics, and a driver for innovation and technology transfer in Europe. CERN is currently undergoing the Future Circular Collider study, a future underground circular particle accelerator with a 90 kilometers circumference and 4 experiments. We are really excited to have Marc here with us to share CERN's vision on big science in Europe. Welcome, Marc, the floor is yours.
Thank you very much, Eva. And I profit to thank also the organizers for having the opportunity to talk about what are the plans of CERN. So thank you very much for the invitation. So let me start by saying what CERN is, which is a research infrastructure for fundamental physics, today with 25 member states, an annual budget of about 1,200 million Swiss francs, about 4,000 employees, but I think what is very special at CERN is the very, very large community, about 13,000 scientists of 110 different nationalities. You see on your right the accelerator complex, and the LHC, the Large Hadron Collider, which is well known, is just the end of a long chain of different accelerators that accelerate particles up to high energies and also the speed of light. So this allows to have a very diverse scientific program. Of course, the Large Hadron Collider is the flagship, but we have a lot of diversity to do physics at lower energy. So what do we do at CERN? I think, as I said, this is fundamental physics, and the questions are very simple. We want to understand the universe from the Big Bang to today, what we see when we look at the universe. And there are many different ways of doing that. Obviously, there is the field of astrophysics that look with telescopes. And at CERN, we kind of go back in time and we use accelerators which allow us to probe matter at a scale of 10 to the minus 18 meters. So therefore, that's why sometimes we say that the accelerator is a big telescope or a big machine. And our questions are very basic. First of all, what are the building blocks of matter? And we have the answer, the particles. What keeps everything together? How does it work? And we say, well, they are the fundamental forces, but also there is the big question of how the universe started and how it has evolved. We have to answer these very basic questions, three main technology pillars. First, the accelerators. You know that the Large Hadron Collider is the most powerful accelerator in the world, also the largest, 27 kilometers of circumference. It has a lot of fun properties, like being the colder place in the universe, have a vacuum environment, which is like the atmosphere of the moon. It takes protons, very, very well-known particles, and it accelerates these particles in different directions at the speed of light, very high energies. And the collision between these two particles, all the energy is converted into new particles that then we study. And we do that with the third pillar, the second pillar, which are the particle detectors. The particle detectors are obviously a marvel of technology, different sensing technologies, very high-speed electronics. And basically, one can consider these detectors like an analog 3D camera, where you have a rate of taking pictures of about millions of pictures per second. And we just select thousands of those pictures and analyze them in detail to know physics. Of course, the third pillar is computing. CERN is well known for providing the worldwide LHC computing grid, which distributes the data we generate to 170 computing centers around the world. And with that, we do physics. Of course, this doesn't come for free. There is a lot of procurement associated with all this technology. And you see in the graph, the procurement divided in very different categories, and I invite you to see and to attend the presentation of Cristina Lara, which is the head of procurement of CERN, that will be explaining this type of data after the coffee break. And basically, the message there is that CERN spends, in average, about 500 million procuring technology, services, and supplies. And where you see a peak is where we are in construction phases. So the peak up to 2008 was the construction phase of the LHC. And you see now a little bit the procurement ramping up because we are upgrading the machine. What we have done with all this, I mean, of course, we have a very rich program, as I mentioned, but I think one of the things everybody knows is that we found the Higgs in 2012. And this was important because the Higgs is it was a missing cornerstone of our theory, standard model of physics. And not only because of that, because it said that our theory works very well, but also explained how the other particles acquire mass. And this was a mystery in the standard model. So we have been, since then, studying the Higgs, how it interacts with all other particles, if it matches with what the model predicts. But the story doesn't finish there, and the adventure continues. We are now programming a big stop of the machine. We call it the next phase, the high luminosity machine that will allow us to study the Higgs with unprecedented precision. But we not only are planning the LHC, we are preparing the future. And I wanted to show you a couple of images about one of the alternatives for the next flagship project at CERN, which is the Future Circular Collider. This will be an accelerator of about 90 kilometers in circumference, which would be at 400 meters underground. So the scale goes up, not only in size, but also on energy and discovery capacity. And this proposal is being presented in two phases. The first one will be an electron machine that basically, what we call it, we want to call it the intensity frontier. Basically, it will allow us to explore nature with extreme resolution, and that's why you see those pictures there. The time scale is impressive. We will, when approved or if approved, start to build in 2033 for an operational phase that will start about 2045, something like that. Once you have this accelerator, once you have this accelerator, next upgrade, and you know that when physicists design infrastructures, one of our qualities is that while we are building, we are already thinking on the next phase of that machine to upgrade it. So the next phase will be a hadron machine, similar to the LHC, but high in energy. And there we don't look for intensity, but we really want to go deeper into the understanding of nature. Of course, the key enablers of success of this project or other alternatives will be, of course, based on the 70 years of experience of CERN, with proven technologies, a very rich infrastructure, also a very experienced community. And the strategy to get this approved is very global with very different parameters, but I wanted to mention in particular the sustainability. I don't have time to talk now a lot about sustainability, but it will come probably on the questions, so I'm going to skip these slides and jump very quickly to the opportunities. The cost of this new infrastructure, of course, is very impressive. We are talking of 15 billions, 15,000 million Swiss francs, which today, with the prices of 2024, is divided, as you see in the slide, with a big component for civil engineering, because we have to dig a tunnel, but the rest, it will go into infrastructure, and obviously this will create a lot of opportunities to participate for industry of the member states. So let me finish by saying that particle physics has a long and ambitious future, and industry is essential to turn our ideas into bold machines, accelerators, detectors, and so on. The involvement of Spain has been essential to CERN's success. Spain has been a very reliable and very successful partner for CERN, and today both the industrial and personal return are excellent. High Lumi, which is the next phase of the machine, and it will go up to 2040, will provide a long decade of opportunities for industry and the scientific community in Spain to continue collaborate with CERN, and in parallel we are preparing the future. And for that, we encourage industry to get already involved at a very, very early stage, because getting involved now, it means stable collaborations, innovation challenges, and opportunities to develop things that will have impact in the countries at CERN and for society at large. Thank you very much.
Thank you very much. Oops. He tenido un pequeño problema técnico. Se me ha caído todo. ¿Veis? Hablamos de grandes tecnologías. We're talking about super mega technologies, and then the basic ones are falling. Anyhow, I just want to warn the speakers that you have the clock there. You've been perfectly right with your time. And if I see that you talk too much, I will stand up and pressure you, you know. We've been threatened before, so we have to finish on time. Thank you very much. It's another league. Sometimes when we see these facilities, it's like, wow, it's super overwhelming. It's wonderful to be part of CERN, and we are very committed to it as a country. So now we continue with ISO. Our next speaker is Professor Xavier Barcons, the Director General of the European Southern Observatory. ISO is building the extremely large telescope, the world's biggest eye in the sky, which will lead to a greater advancement of astrophysical knowledge, allow a deeper exploration of our universe, and give sharper views of cosmic objects than ever before. The ELT is a massive project, and to make it happen, collaboration with the European industry has been essential. ISO is also operating world-class telescopes like the Very Large Telescope and ALMA, the world's largest ground-based facility for observations in the millimeters of millimeter regime. Xavier, ISO's great achievements are an inspiration to all of us. So welcome, and please inspire us.
Thank you. Thank you. Good morning, and thanks very much for inviting me. I have a little challenge here because I have the slides from Mark.
You could try.
So I can inspire you about fusion. Could you please change the slides to the ones from ISO? That would be great.
Necesitamos cambiar las diapositivas al Xavier Barcons,
Estas no son
porque no
las
son las suyas.
Don't worry, I can talk in the meantime. Okay. So, ISO, yes, business card. We're an intergovernmental organization, very much similar to CERN, much smaller, 63 years old, 16 member states. Yes, here we go. 16 member states. Spain joined almost 20 years ago. It's, yeah, quite an achievement. Yearly income, 230 million. We're spending now with one of these big construction phases, as Eva said a minute ago. So we're spending now at around 400 million per year, but this will go down at some point. Important, we're a multi-program organization, so we're not just one research infrastructure. We're operating several, we're developing others. This is why we were born. We were born to design, build, and operate world-class astronomical facilities on the ground and to foster cooperation in astronomy. And this is important to keep in mind. What do we actually deliver? We deliver these three things: high-quality astronomical data to a community of maybe 25,000 astronomers in our member states and beyond. Groundbreaking facilities. This is really the topic for today. You know, the facilities, how do we build them, how do we operate them in a smart way, and also engagement. That's a super important part of our mission. We engage with scientists, with R&D institutes, with industry, and with society at large. Just to show you a couple of figures, our observatories generate lots of science every year, comparable to any other big astronomical facilities, either on the ground or in space. That has generated lots of scientific breakthroughs during the years, including several that have led to Nobel Prize winners for a variety of topics in the field of exoplanets or the acceleration of the universe or black holes. This is the very first observatory we established. It's now what I call a Ryanair observatory. We try to operate it as a low cost. It still has a few facility telescopes which are producing important science, but of course that's not the most luminous part of our research infrastructures. This is one of them, very large telescope. Just to confuse everyone, it's not one telescope, it's several of them that can work together. We operate them all together with a huge variety of instruments. And this is the cathedral of optical astronomy in the world. It has unique facilities like an infrared interferometer. And a trick for this to work is that the instrumentation, the cameras, the spectrographs, and so on, we don't build them. It is consortia of R&D institutes in our member states who build those instruments together with us. And that's a very positive feedback loop with a lot of technological engagement. ALMA is our other big observatory. This one is a partnership with the US and with Japan. It's already 12 years in operation. I forgot to say that the Very Large Telescope has been operating for 25 years, so we're now in this obsolescence tackling period together with big investments in upgrades. ALMA is a global observatory, actually. I mean, as I said, it's United States, is also Canada, Japan, South Korea, and so on. Complicated thing to govern, I have to confess, but very, very productive. And this is what keeps me awake at night, the Extremely Large Telescope. It will be the largest optical infrared telescope in the world ever conceived. There's another 2 projects trying to take off from the ground. The total additional spending in our organization is about 1.6 billion in this project. I should add about 30% of overheads that we never count, plus big investments, again, from R&D institutes in the member states to build the instrumentation. So total rough estimate of the cost is about 2.5 billion euros. We expect to achieve first telescope light in March 2029 and the first scientific verification with the first instrument around December 2030. We're at about 70% completion of the construction. You can see a number of items here, including the optomechanics and test benches and other things. The Secretary General was at the construction site a few weeks ago. She can testify it's an amazing machine, what we're building up there. This is the last one that is also in our portfolio. This is the southern array of the Cherenkov Telescope Array Observatory, a very high energy gamma ray facility. We're hosting the south side, a picture taken last week of the foundations already there. So, science data, that's super important. We see that about 30% of the science that we generate comes directly from the use of archival data. So we have been spending, before this open science concept was even invented by the European Commission, we were doing open science. All our data is in archives, it's curated, we provide the tools for the community worldwide. That generates about 25–30% of the papers of the science that we deliver. This is our ecosystem, very similar to any other big research infrastructure. Our member states, the scientists, the R&D institutes, the industrial partners, and also the service providers. Industrial partners, this is what this is about today. Those are extremely important for us. The ELT, by the way, the amount of contracts that we have placed, it's about 1.2 billion. So it's really a big investment, and it's in a variety of topics, most of them high-tech with high added value. I need to skip this. Now, as at CERN, we're also looking forward. What are we going to do after the ELT? Certainly, we won't solve all the questions about the universe. So we have started a process called Expanding Horizons, together with the community, to devise what are the big scientific questions that we will like to answer in the 2040s and for which we will not have a facility to do it. And we're on that phase now. Once we have an idea of these questions, we will start thinking about what type of infrastructure are we going to need. That can be an upgrade of our existing observatories or a new one. That will come as a second step. So transformational facility 2040s. Those are the 3 keywords here. It's a starting process. Of course, when we know what we would like to do, the engagement with industry will become super important. One slide about sustainability. We're going to come back to this. For us, sustainability is a very global concept involving environmental, social, also financial aspects. And that's it. Thank you.
That was great. Thank you, Xavier. Fantastic. Thank you so much, Xavier. It's so exciting as well. And now I welcome Marc Lachaise, Director of Fusion for Energy, for his presentation. Fusion for Energy is the European Union organization managing Europe's contribution to ITER, the biggest scientific experiment on the path to fusion energy. Paraphrasing Fusion for Energy's motto, the ITER project aims to bring fusion, the energy of the sun and the stars, to Earth. Eventually, fusion energy will be one of the pillars of the future energy mix in Europe and worldwide. European industry is prepared to play a major role, leveraging on its involvement in the ITER project, which has built valuable capabilities. So the future is nothing short of exciting. Mark, we are eager to listen to your views on the role of the European industry sector and what the future will bring. Thank you very much.
Thank you, Eva. Good morning to all of you. So we will do it in English, but we have here some colleagues and I speak a bit Spanish if you want to engage with us in Spanish as well. Fusion for Energy, probably most of you are familiar with what we do, but it's good to remind. I always said that the main asset we have is our people. We're learning from our projects, but we have 465 colleagues passionate about fusion, passionate about Europe. The budget in the last, what we call MFF, so the multi-annual framework of the European Union, was 5.6 billion. I can tell you that the next one should be on a similar level, although the process is still ongoing. I had a chance to lead this organization for a bit more than 2 years now. And our role, as it was said, is to provide the European contribution to fusion projects, mainly ITER, but also we worked with Japan on the biggest tokamak on Earth, which is the biggest fusion installation we have today, which is done 50% by Europe. And recently we signed, and we're happy to join the family of Doness, which is a new project in our portfolio, and we will support the actions of Doness. Of course, we are multinational, multicultural, 23 nationalities in the team. Here I put a simple slide to, this is maybe something which is start to be outdated because it's the strategy we had a few years ago. We need to update this, and this will be done very, very soon. The Commission will come with a new European strategy, probably early next year. And we know that some of the member states, and I know Spain is working on that as well, are building some fusion strategy. But here you have a bit the flavor of the journey. The objective clearly, as Fusion for Energy, as Europe, is one day to have the ability in Europe to construct, build, operate our own fusion facility for commercial fusion. This means delivering electricity to European citizens with something which is manufactured and built in Europe. This is still a long way to go. So how do we do that? First, we learn and we contribute. So we managed to build together with Japan the biggest tokamak, and we are supporting ITER by delivering components. Today, we deliver, roughly speaking, 45% of the ITER value on a day-to-day. And the Spanish industry, as it was said, is the third supplier of ITER from Europe. So this is quite a big achievement. We have also, as you see here, Doness, the consistency of Doness, and I'm sure Angel will explain. It's really to make sure that we learn about the materials, because fusion will need very specific materials we don't know today, and this is all consistent. So this is our roadmap. Fusion for Energy, this is the vision, and it's quite simple. We articulate this on 3 pillars. The first one is Fusion for Energy is a delivery organization. I was very happy yesterday to discuss with some suppliers, and I hope we'll have the chance today. We need to deliver projects. We need to deliver them on time, on quality, on budget, and we need to do that with industrial partners. Why? Because we are accountable for European public money, and also because tomorrow fusion will be a competition. So we have to be efficient in our ability to deliver projects. The second pillar is about the people. I was mentioning the FOE people. But also fusion is a story of people. You might meet people working for fusion for 20 years. And we know that we need to train the generation because we won't crack some of the things for a few years from now. So this is an intergenerational journey. And then the competitive supply chain is one of the pillars. So that's why it's important for us to be here and to engage with you. This is a picture of ITER. I was checking this morning, I was talking with AI. So as European, I try to use European AIs, if you can take the tip, they're quite good. And I was talking with Mistral, and I asked the comparison of the size of the tokamak building you see here with one of the buildings you might know in Madrid, which is Casa Real de Correos in Puerta del Sol. This is 5 times bigger in terms of volume, just to give you an idea of the size. ITER is going well today. The assembly is back on track compared to a few years ago, and we're proud to announce that again this year, the delivery of things are on time, and the assembly of all the components are even slightly ahead of schedule. So ITA is in the south of France, as you know. Here a few figures. Just to give you the size, I added the one of Casa Real de Correos, the cost as well. The objective is not to reach the level of ISS, of course, but it's just to give you the nature of what we do. And basically, this is comparable to the biggest project of mankind in the last generations. This is an example of what you manufacture, some of you for us. We have here a few pictures. Happy to go into the details if you wish so. Quite a lot of heavy manufacturing, very experienced people needed to do things which are very often first of a kind and something which are unique for most of you. Here are a few pictures to give you the size. We see magnets, we see the vacuum vessel. A bit of business figures. We have invested till now about more than 7 billion euro in the EU supply chain, and we're really proud of that. We managed today a portfolio about 5.5 billion euro of open contracts, and we will keep on the same trend. So about 500, 600 million euro per year in the coming years definitely are secured, and we will need to engage with you. We have a network of more than 2,000 companies, including some of the Tier 2s, but clearly we employ quite a lot of people through those contracts. The latest estimation is that in the recent years, we created 30,000 year jobs thanks to fusion in Europe. This is one of the figures you see here. Creating innovation as well, and a few spin-offs coming from fusion. Some people might ask us, why in the roadmap you haven't mentioned startups? Because it's new. There is something new in fusion, is that we see private startups working on fusion, making very bold commitments also to the markets, raising a lot of money. So as Fusion for Energy, we engage with them to support. This is the risk in terms of finance and in terms of investment, but we really want to see if we can support them, of course, in particular, the European companies as Europe. You need to be mindful that only 5% of the international private money going to fusion today is going to Europe. The vast majority is going to the US and to the UK. So just food for thought. So we've signed a number of agreements with startups. We are also working, and I know that some of you were part of this journey, on technological mapping. So you see different components. So we take a subject and we act as a hub, having all the industry and the laboratories coming together to work on what could be a European roadmap. We promote technology transfer, and I think it's true for most of us. What we learn on fusion can be used in other sectors. And we have a transfer award that we give every year as well. To conclude on the Spanish participation, apologies if maybe there is one or two logos missing, but this is at least the key partners we identified. Total value of contracts, it's 2 billion since we created Fusion for Energy, which is really important. And as I said, Spain is the third beneficiary of Fusion for Energy contracts. As a conclusion, I think we have a lot in common with other big science organizations, and we want to work together also to engage with you on a more solid basis. ICFO is a catalyst of what's done in the laboratories and the industry, and I think big science is playing a big role. It's science diplomacy. It's going further altogether to serve the next generation in all the things we do, and in particular in fusion. Thank you.
Thank you so much, Mark. Thank you so much, Mark. And now, last but not least, we have our speaker of this session is Dr. Ángel Ibarra, Director General of the IFMIP Dones Spain Consortium. IFMIP Dones, currently under construction in Granada, is a major international scientific infrastructure project aimed at supporting the development of fusion energy by testing and qualifying materials that will be used in future fusion reactors. For our country, IFMIF Donez is a strategic project to which we are dedicating significant efforts, as we are firm believers in its scientific, industrial, and socio-economical potential. Angel, we are looking forward to learning about the progress in the project and your views on the role of this facility will play in the future. So welcome, the floor is yours.
Thank you very much, Eva. Thank you very much to the organizers of the conference for giving us the opportunity to talk to you about Donez. This is not the first talk about Donez. We have yesterday already a roundtable, and there will be another one later on talking about different aspects of Donez. So I will try to focus here mainly on the way in which we manage the relationship with industry. In any case, the first thing to clarify is that, of course, we are not as big as my predecessors. We are a really project focused on solving one specific problem of the development of fusion energy as an energy source. You can see here a sketch on the way in which the development of fusion as an energy source has been thought along the years, that I think is still the key. It summarizes also the key steps that need to be developed. Up to now, along the years, it has been made a lot of different type of machines that has provided to us an understanding on how we can control fusion reactions, and all the results that we have up to now shows that fusion is plausible. We think we know how to manage fusion. Then we are now building ITER, the ITER project that has been already explained by Mark, that will demonstrate that fusion is feasible, because it will show that we are able to produce fusions and fusion reactions, and it is possible to get an energy gain, and we control all the technology related with this. But there is still a number of topics to be solved that cannot be solved in ITER, and we need to demonstrate that it is possible to build a fusion reactor. There are still a number of topics that needs to be solved, and one of the key topics is related with the materials, material behavior, and especially the material behavior in the long term. Of course, this problem has been identified many years ago, and it has been, this strategy, this approach has been included, defined in the different roadmaps or different strategies that has been developed in the past, and the ones that are being developed right now. So how we want to solve this problem? The idea is that we cannot build a fusion machine to solve this problem because there are too many unknowns in this process. So we are trying to build a tool that will allow us to explore these problems, and this tool is an accelerator-based fusion-like neutron source that will allow us to generate an environment similar to the one that you will have in a fusion reactor, but at much lower cost, and of course, in a much smaller volume. This accelerator is a deuteron accelerator that accelerates deuterons up to 40 MeV. That is a very low, relatively low energy. It's relatively easy to do this, but this deuterons hits on a lithium target, and then there is a nuclear reaction that produces neutrons similar to the ones that you will have in a fusion reactor. The problem is that we want to have a lot of neutrons, and that means that we need to have a very high current, and we are targeting to build an accelerator with a current 50 times higher than the ones that we have now running. So that means that we are exploring the limit of the accelerator technology. We are building an accelerator that will put 5 megawatts of power in the target in a surface like this. So it is a unique facility. It is a unique facility because it is exploring a technology area in the accelerators technology that is not so well explored. It will be one of the most intense accelerators in the world. It will have the world's largest liquid lithium loop in the world. So that means that there are a number of other challenges. It means that it is a challenging machine, even if it is a tool that we want to use to solve the fusion problem, the material fusion problem. It is a challenging machine by itself. And the main relevance of it is that it will be the only experiment, the only machine that will allow us to reach end of life of the components or the materials in a fusion reactor in the near future. There is no other machine that will allow us to do this kind of experiment. So that means that, as we mentioned yesterday, that means that anyone that wants to build a fusion reactor, a real fusion reactor, a commercial fusion reactor, will need to develop experiments in our facility. Okay, so I don't want to talk too much about the accelerator. What I want to now to emphasize is how we manage the relationship with industry. Here in this slide, you have a sketch of the type of technologies that are involved in the building of this machine and in the operation of the machine. And you can see that almost any kind of technology is needed to be developed for the construction of the machine. So that means that almost any kind of industry is of interest for us. And one of the key points is that we have developed an IP environment, an intellectual property environment, that we think it is worthy, it will help to the companies and to the countries to invest on the facility. So if we take this into account, it is important to emphasize that I think, and it has been shown in the previous presentations, that in all big science projects, we need to involve industry as soon as possible. First, because the project needs to know if the ideas that we have are feasible, and second, also because it will help the companies to better know the project. And to be a little bit provocative, I think that this early involvement of industry is also very important because this will maximize the impact on the society. All these technologies that are developed later on are transferred to other economical sectors, and this will have impact on the society. Sometimes, I would say, to be provocative, sometimes it is more important, this transfer to the society, this impact on the society, on the different technologies that are developed, than the scientific objectives of the facility. Okay. This relationship with industry has been especially true in the case of fusion. From the very beginning, Spain and in the different projects that has been developed by Spanish institutions, the relationship with industry has been very important. And we have tried to promote the relationship with industry as much as possible. This has, as a consequence, very important economical returns in the long term. It has been already mentioned several times, but in the last 30 years, I would say, we built TG2, that it was mentioned yesterday also at Tiamat. It was built by Spanish industries up to around 60%. Then Fusion for Energy is now located in Spain with a very significant economical impact in the Barcelona region. There are the number of institutions, research institutions, and companies involved in the Eurofusion consortium has been very significant during the last 10 years, in some cases being the second country in the Eurofusion contributions. And as it has been already mentioned by Mark, the ITER contracts granted through Fusion for Energy to Spain is the third in total, and this has been maintained like this in a regular basis during a number of years. So, similarly, it's in other projects like the broader approach projects, the IMIFEBEDA project, the Spanish contribution that was very significant has been spent in around 95% or 99% in Spanish companies. And this has been further reinforced when we talk about DONES. In the case of DONES, we also defined a strategic objective to try to work with industry as much as possible. And one of the main tools that we have used to be sure that the companies knows about DONES and knows the type of technologies that we need to involve has been using Cedati tools, the Misiones tools, and you can see that in the last 10 years we have contributed to develop a significant number of projects with a significant number of companies, mobilizing more than 80 million of private-public collaboration that is now so much in favor, but this approach was started many years ago. So in summary, this is translated today that all the contracts that we have issued in DONES has been granted to Spanish companies, and they were open contracts at the European level. And you can see the situation that in which we are today. We have granted 3 engineering contracts to different companies, and we are now in the process to grant a very important one, 175 million, for the engineering and construction activities that need to be developed on site. And that's all. Thank you very much.
Thank you very much, Michael. But now, after these fantastic presentations, I mean, congratulations, because you are heading state-of-the-art infrastructures. I mean, we are very pleased to be part, as a country, of all of them. And now we are going to have half an hour debate altogether. We have some questions here, but of course you can state any other question. You feel free to do it to our speakers. But one of the words that is being repeated, and you pass over a little bit quicker than expected, is sustainability. How your infrastructure is planning this sustainability? How is your action for sustainability? For example, we start by Mar at CERN. What is the plans that you have?
Thank you. So CERN has a long-standing commitment to sustainability. In fact, looking back, already in 2015, CERN established a number of bodies that then help to implement what we call environmental and sustainability protection, like Energy Management Panel, Environmental Protection Panel. So this dates from 10 years ago. And I think what has been a game changer was when our current General Director, Fabiola Gianotti, included sustainability from the top to the bottom in the objectives of the organization. And that meant that once you have this strategy as a top objective that was honestly, enthusiastically embraced by the rest of the organization, bottom up, it helped a lot because it defined that, first of all, we want to report in a very transparent way, of course, following the standards. The second, that we want to set targets and that the strategy is converted into operational actions. Just to give you an example of them, we are now building and will be ready for commissioning in the winter of 2026. We are taking the excess heat of the accelerator and of a data center, and we will be providing about the 80% of the heat needs for the site, which is very significant. So these things, they need important investments up front, but it has two advantages. First, that it shows that sustainability is a serious matter and is something that is there to stay, first of all. Second, it gives credibility also for the next projects, and for a future circular collider or an alternative project, this will be key, not only because it's a responsibility to do it like that, but it's also a question of acceptability of the public and the society for these projects. And in the FCC and Linear Collider and many other projects, this is embedded by design. It can just not happen with that component added.
Thank you very much. Xavier, how your organization define this sustainability?
Yeah, so we actually put together and released the sustainability strategy 3 years ago, which contemplates the whole of what we understand sustainability today, including environmental, social sustainability. This is super important for us. Remember that our telescopes are in the Atacama Desert in Chile, And also, of course, financial sustainability, that's also important. So we've released that strategy. It identifies material topics where we can make a difference when we compare with the UN Sustainable Development Goals. There's about 13 of those. We have targets, and we're starting to deploy projects to get to those targets. And maybe I can give you a couple of examples. One is to reduce the carbon footprint. Our target is to cut it by half by 2035. The biggest pocket there is energy provision. The second one is supply chain. Third one is movement of people and goods. We've made a big step with energy provision. We have, you saw it, we have a huge photovoltaic plant in the middle of the desert in our headquarters in Germany. We also procure only green energy, and so on. So there's a number of actions there. I want to mention another one which is important, which is sustainable procurement. The companies that are our suppliers, we cannot accept that they don't have, for example, diversity targets or that they don't treat their people well. So all of this is part of a big effort that we're putting together, because sustainability is one of our values. And a value means this is an assumption for everything we do. It has to pervade in all of our activities. We will issue our first EU compliant sustainability report next year, and we will keep monitoring over the years to come after.
Thank you very much, Xavier. I suppose that because we are talking about this big word that is sustainability, and it's nearly like a bucket, where or you said like a square, where it has several edges. For you, for Fusion for Energy, what will be, already Xavier mentioned like 4 different ways of sustainability, but what kind of sustainability is the main pillar for Fusion for Energy? Or you share the same as CERN and ISO?
I would say we share very similar things. First of all, we share that it's an important value. And also we have this in mind because the purpose of fusion is sustainability itself.
Exactly.
The objective to have fusion energy, which will be clean, safe, which will solve a lot of the problems we have today, is the goal of itself. I maybe just take one of the points where I can expand and give a different view is about sustainable procurement. I fully agree. And we started also a collaborative approach with the supply chain. We had supply chain days in Barcelona a few months ago. One of the topics was sustainability, but not a top-down vision, but also we have what we call participative workshop, where we talk to the supply chain to say, okay, what's your knowledge? Because we think that we can learn from others, from you, but also from you here, and to build together what could be, in terms of procurement, the sustainability we will embed. And I fully agree, and talking in the name of the EU, it's even more important for us. We need to make sure that this is cascaded properly in the supply chain, because we place such big contracts that those contractors, they have suppliers, sub-suppliers, and at some point there is a risk to lose things and where they're done. So sustainability in procurement is really key. We're moving with the supply chain, and it's one of the key values for us, definitely.
Fantastic. And now, Angel, as a John, no, the baby of these infrastructures, I suppose that in your action plan, you're also defining sustainability for IFMIF-DONES.
Yes.
What is the main objective goal?
The way in which we address this, of course, is a topic that needs to be considered from the beginning. It's a little bit different because we are building the organization right now. So in the way that we are addressing this is mainly putting sustainability requirements from the beginning in the engineering design of the facility. So for example, I mean, we try to take this into account in the work that we make internally and in the work that we ask to the companies to be implemented. So just to give an example, for example, very recently we have detailed discussion, I would say a strong discussion in the engineering team to review the way in which we were planning to do the cooling of the facility, and as a consequence of this, we have reduced the water consumption by 80% in principle. So this type of approach takes into account these things. Also in the environmental aspect, we are planning, even if it is not a requirement for us, we are planning to implement the 14001 standards for managing environmental issues and similar things like this. In the social aspect that you mentioned also, this is also for us very important because we think that to get the support, the local support along the time will be very, very important. And I think that we have succeeded to get local support in Granada, in the Granada region, in these years, but we are thinking all the time how to maintain this along the time. I'm sure that at some moment in time there will be some questions coming, and we want to be ready to be able to answer these questions, or even to answer the questions even before we get them. So we are trying to work from the engineering point of view to take these aspects into account from the beginning, and also from the social point of view, we are trying to make a specific effort in this aspect.
Very good. So we are all facing the right way to continue improving and be more sustainable. Of course, another of the topic that we always discuss is like European research infrastructures are one of the main actors to strengthen European competitiveness. But of course, many of them are based on basic science to discover, as we saw, you are putting these Nobel laureates to discover knowledge for the sake of knowledge, which is good. I mean, I'm a full supporter. But how do you, because we were also discussing yesterday how important it is to put this basic knowledge into the transfer of knowledge and their innovation. How are your infrastructures also seeing or promoting innovation? Mark, maybe we can start by fusion for energy.
Okay, thank you. It's a very good question because fusion in itself is about innovation. How we do that? I think I see fusion for energy as a form of connection between the science. I mean, fusion is really into deep science, and if you have a look in the details, there are things still to be solved. So there is a deep science, but at some point we will need to build things which are tangible, which are industrial. And I think the innovation is coming from that, is how we can have big science things coming from the lab cascaded to the supply chain. And I see this only through dialogue. I think coming from the industry, I was really surprised by the complexity of things we do in fusion. And I see that the dialogue with the supply chain is first of all, helping the supply chain, the industrial supply chain, to innovate, because we have things which are new, but also they bring a bit of reality touch to innovation. Innovation needs to be something tangible, something which works. So I think this dialogue that we try to push between the labs and the companies are really important. Then innovation also, it's what will make the difference internationally. I mean, Europe is not known to copy, to do things quicker and cheaper. We're known because we have the ability to do things differently, to be creative, to innovate. So I think it's really also strongly linked to competitiveness, innovation and competitiveness. So this is in a short answer what I would say for fusion for energy.
Thank you very much, Mark. I have a question for you, Mar. We are talking about particles, okay, and us as people doing scientific policies, and also just going to the community to ask for money, the tax money to be used. If I have to convince society what is the value of such a big project, 100 kilometers, which means it's transferred to millions and billions, as you mentioned, how would you convince, based on this transfer of knowledge, to convince society that the investment of this money, of the tax, instead of going to health, for example, is going to discover physical particles? How do you transfer it to convince society that this is a good investment?
Yeah, that's a very difficult question, right?
That's why I asked you to give me the answer.
Yes, absolutely. You know, it's very difficult to put a cost value to knowledge. It is very difficult. No, I think nobody has managed to date. I think I can translate your question and say, you know, when the people start to read in the newspapers, the Higgs is discovered at CERN, and many schools that comes to CERN very often, they say, but is it the Higgs going to change my life? And I said, well, it has already changed your life, because to discover the Higgs, we had to develop to date a number of technologies that had such an impact in our society. Of course, starting from the World Wide Web, I hate to mention this as example because it's already a bit old.
Yeah.
But it is true that has changed the society, and it is only in a lab or in an infrastructure like ours that this could have been possible, because you can take risk, you are not scared of risk, innovation is in your DNA. So that's one part of the questions. And then second, you know, when you talk about fundamental science, it is very obvious, and all these research infrastructures already show that basic science is absolutely linked to innovation. And innovation and science is a way of thinking. It's also educating the society to be more critical, and this is very important today. Innovation has to be explained to very young people and people for all generations and from any other fields. So I think the question is what type of society we want. And by investing in research infrastructures and the technology that comes with, I think is the right bet.
Fantastic.
Thank you.
Good answer. Thank you. I will use it also for convincing people. Xavier, looking at the stars, that's beautiful, isn't it? I mean, we are all convinced that it's great, but how is to translate these discoveries into innovation, and what is the way to improving, if is needed, this transfer into innovation?
So the key point here is that all of our research infrastructures are science-driven. That means that the purpose of building these big infrastructures is to achieve science knowledge. That's undisputed, right? But don't forget that what we are building, it's always something that was never built before. We're building one-offs. We're building prototypes. We're not going to a shop and put something in our facilities. So that is where innovation enters into place. Our contractors, the companies, our industry partners, they often complain they don't make a lot of profit with us. Well, I agree with that in monetary terms. But what they gain is what you said before. It's knowledge. Knowledge, yes, transferring knowledge is important. You have to generate it first. So our facilities are a big machine to generate innovation and knowledge. And in all these projects that we've been working during decades, you have seen this progression. Companies that started to work with us, struggling to deliver our very demanding requirements, then they go to the market and make a business out of it. I only regret that maybe, at least in the case of my organization, we should be perhaps able to spend a little bit more money on blue sky technology development, right? But when you have such a demanding requirements to build our facilities, that's also a bit difficult. But in essence, by definition, we require innovation to build and develop our facilities, and we generate it.
Thank you so much. And now that you're also, as the young infrastructure, when you plan your key performance indicators, how much of them are just planned to be innovative? I mean, based on innovation. Do you have a number? Have you just planned ahead?
I would say no, not really. But in our case, I think that innovation comes naturally in the line that you mentioned, Xavier, because the key point is that innovation comes because we ask the companies to do things that are impossible. And then they are forced to develop something that they, a few years before, they were not able to do. and then innovation comes naturally. Besides this, it is true that, as I explained in my presentation, we actively try to promote development activities with companies much earlier before the contract that we are going to issue, because we want to be sure that the companies are familiar with the type of problems that we need to address. And from these projects, we also see that significant innovations came up. There is a further comment on this that I would like to make, is that the case of fusion is a little bit, if you want, different. Of course, there are basic results coming up, but the objective of ITER, the objective of DONES, is really something that is applied in some way, because we want to develop a new energy source, and this is something that will have a very significant innovative impact in the society by definition. So we have impact in the innovation from the objectives of our facilities and also from the way in which we develop the facilities.
Let's talk to you now, the audience. How many companies are here? Like, hands up? I mean, I just take the question of, or just the point that Angel made. How many of you were forced to be innovative? That you did something that it was completely unthought before? How many? I see, let me put my glasses on because I don't. 1, 2, 3, 4, something. Very good. Can you give us an example, please? The lady with the red jacket. Oh.
Teresa.
Teresa.
Empresarios agrupados.
Sorry, Teresa, I didn't know your name. It was
No, my name is María Teresa Domínguez. I am leading in Empresarios Agrupados, the business unit of nuclear. We are lasting the last 40 years working already in fusion, okay? The red jacket is because Empresarios is red, okay? Okay, how we face, yes, we almost in all the contracts, they have been something different from what was the normal activities in Empresarios. We are even working in nuclear. We have a very good experience in nuclear, and we were facing this mainly ITER participation, considering that we know everything about nuclear, and it was easy, and actually is not the case, has not been the case. But at the same time, I can say that it has been really a great opportunity for Empresarios. We have developed in instrumentation and control, in mechanical, in simulation, in all the fields on which we are working, different things for fusion, mainly in our case. And of course, we like to continue. We will have later a presentation of what is our vision, and we would like to support the acceleration of the fusion program. Means that in a case of Empresarios Agrupados, it has been a great opportunity to participation, mainly in fusion. Thank you.
Thank you very much, Teresa. And I think there were 2 or 3. Hands up again, those that had to do innovative, super innovative. There's your name? Yep. Someone that wants to participate, because I want also to ask you if this innovation made you unique, and how many of these infrastructure called you after this uniqueness? Someone that wants to answer here? It was no one became unique. This is
yes.
yeah. There's a, if you give us your name and introduce yourself, would be great.
Thank you for the opportunity. My name is Marisa Garcia. I'm the director and owner of a company called Fractal that this year we are 20 years old working in astrophysics. We started working together in one of these facilities, not that the GTC project office, and then after that we decided to start a company to work for other telescopes, in particular for ESO. We are working with UC and for Mosaic. But in the case of innovations, we have done several things, started like prototypes that then went into real units in different instruments. In particular, we have been working for almost 15 years in developing diffraction gratings with different kind of approaches, different from the standard ones. And I think we are unique in that sense because we are a company completely focused on professional astrophysics and instrumentation. So I think it's what we are and what we want to be.
Wonderful, because this is really, I mean, this interaction among stakeholders that we do, which is great, and I insist, infrastructure to get knowledge, I think is the beauty of science, knowledge, but then also how important it is to engage the machinery of all the stakeholders together. And now, I don't know if any of you are planning to get into business, I mean, to start these small, medium companies. I would like you to have this discussion about which kind or what kind of advice you will give to people that are thinking to start small or medium-sized companies to get into this finally huge business now that are research infrastructures. I can start by you, Angel, that I always leave you for the end.
I mean, to give advice to people that is ready to invest in science is a little bit difficult for me because I'm not doing this and I am a permanent position at CEMAT, so it's a little bit, I don't know how to say, okay. But I would say, to me, maybe the main advantage is that or the main advice that I can give is to be patient, because I have the impression that the work to start working with big facilities requires time. I mean, you need to start to do something, and maybe the contract takes 5 years or 10 years or 10 years to go out, and that means that you need to continue to be active during long periods of time. So that means that, of course, you cannot wait forever. That means that you need to work in several lines of work if you want, because, okay, contrast takes a long time because usually we are unique facilities and funded by public systems, requires a lot of time of incubation. Engineering work, it takes a lot of time. So, I mean, it is not a fast process. And from this point of view, you must be prepared for these long periods of time. So you must think on this also. The other aspect that from my point of view is also very important is that you should not be focused too much in your very good idea, the one that you have. You need to really try to understand what is the problem that this facility has or several facilities has, and to try to adapt yourself to the problems that you are able to identify, and not so much to focus only on in something that you think is a good idea. So you must be flexible from this point of view.
I like this flexibility. You always leave me just to keep on. Mark, talking about this flexibility that Angel mentioned, do you have people or small companies knocking your door, or you call them and design together what you need? How does it work? Or you have both casuistic, that you have the idea, you design and you call the company, open the procurement and everything, or sometimes maybe they call you and say what you need. How is the approach for these needs?
It's a very good question, because we are linked also to some procurement rules. So we have to go to the market when we know what we want. But I want this to be a bit more flexible, as you said. And I think we have a lot of interest to listen, to know what companies can propose, and to have this connection between our needs and their ideas. To answer the other question, I think the main message to SMEs is that you should not be afraid. First of all, SMEs are the heart of the European economy. 99% of the companies in Europe are SMEs. You employ as SME 80 million Europeans. So, and our main base as Fusion for Energy is SMEs. So you're welcome, because big companies, sometimes they're not ready to go the extra mile as you are. They're not coming because we don't offer yet series and visibility, because they're difficult to deal with as well. They're a bit more risk adverse. So the message is that, first of all, don't be afraid. Be proud of what you do and come and explain. I think you have the opportunity here, or you can knock at the door just to say, this is what we do. We do it well for CERN. This is already giving an attention, because this means you cracked a few things, or for others. But be proud of what you do. Know your limits as well, because if you feel that you embark a journey which is difficult. But I think the contact is really important. And this is my job as a manager of FOI, to make sure that we listen. And my commitment is to listen ideas and then to make sure this connection is happening.
Thank you so much. We have 1.5 minutes left. And I don't know if the audience has any question to our speakers. Any one of you that feels inspired? Carlos, please. You have 1 minute for the question, because otherwise they will tell me off.
Yes, it's a very short question, something that has been actually highlighted by all the speakers, the importance of crosstalk activities in different big science pillars. But I think that the Director of Fusion for Energy made a very good point, how a clear mission for ITER can develop a technology development program that you call TDP, where you already identify technologies and you do this identification using different big science facilities. It was the case of CERN and the case of fusion. And I think this is a very important message for industries, because this opened the market business, but also very important for these challenges. Because at the end, innovation quite often comes for people doing something else when moving to other fields, not very far, but still far from your urban area. So I think this is a very important message also for industries.
Thank you so much, Carlos. For now, we have only some seconds left. It's been such a big pleasure, not only sharing the floor here with you, also to have the opportunity to visit your facilities and to see it live. I will go to ITER without any doubt as well. And thank you so much, because your work is so important, not only generating knowledge, but also engaging all this machinery that will develop our competitiveness in Europe. So thank you so much, Angel, Marc, and Xavier, for sharing the floor with us. Thank you.